Calculate the standard deviation for the random variable x. The standard deviation, or sigma, is equal to the sum of the deviations, that's x minus mu, squared. The deviations squared times the probability of that deviation. That's it. Remember, this symbol means add. We're going to add the sum of the squares of the deviations times their probabilities. So we have the probabilities here, so we could use a column of the deviations, but in order to calculate those deviations, we need mu, or the expected value. So that's where we start, with the expected value. And to do so, to make our life a little bit easier, I'm going to add a column here, and this is the x times p of x equals x column. This will allow us to calculate mu, the expected value. Negative 2 times 0.85, that's x times p of x times p of x. So we take the first column times the second column. We have negative 2 times 0.85, that's negative 1.7. 8 times 0.01 is 0.08. 18 times 0.004 is 0.072. And 98 times 0.01 is 0.098. So if we add these together, we get negative 1.7 plus 0.08 plus 0.072 plus 0.098, negative 1.45. So the expected value of mu is negative 1.45. Now, we need another column. We need the x minus mu. So this is x minus mu squared. We're going to take these squared deviations, put them in a column here. So, deviation here, x minus mu. X minus mu is negative 2 minus negative 1.45, or in other words, plus 1.45. So negative 2 plus 1.45 squared, 0.3025. So let's see, 0.3025. 8 minus negative 0.145, so that's 8 plus 1.45 squared is 89.3025. 89.3025. Now we need 18 minus negative 1.45, so 18 plus 1.45 squared, 378.3025. And finally 98 plus 1.45. 98 minus negative 1.45 squared, 9890.3025. That's x minus mu squared. That's this part of the formula. Now we need to multiply those numbers by their probabilities. So we're going to add one more column to the table. And we'll put in here, this guy times this guy. So I'm going to have to abbreviate. That's x minus mu squared times copy this column. So I take 0.3025 times 0.85, and that's 0.257125, but I'm going to round that to 4 digits. 0.271, nope, sorry, 2571. Next, we have 0.01 times 89.3025. So multiplying by 0.01 just moves the decimal point a couple places. So we have 0.8930. 0.004 times 378.3025 times 0.004 is 1.51. 1.513. 2. I had a 2 at the end. 98, sorry. 0.001 times 9890.3025. We have 0.001. So we move the decimal point 3 places. 1, 2, 3. That's 9.8903. And now we add those up. So the sum, we have to sum these numbers. So we add up this column, 0.2581 plus 0.893 plus 1.5132 plus 9.8903. 12.5546. And now I see I made an error at the beginning. This is not the formula for the standard deviation. That's the formula for something else. We need a square root around that whole quantity. So sigma for this problem, final answer, sigma is the square root of this quantity. This is the sum. So I have this number now, and I need to square root it. So we have the square root of 12.5546, which is approximately 3.54.